Homework help with Jen. We're still working on chapter 3, and what I'm going to do here is that problem 47, 49, 51, 53, 55, and 57 are all linked. So what I'm going to do is I'm going to do part C of 47. We're just going to follow it through all the way. Okay? So part C, C says basically of 47 that we need to find the molar mass of this compound too, ammonium dichromate, okay? And it's not really a molecule, it's a formula unit because it is an ionic compound. So here's our anion ammonium and our anion cation and our anion, the dichromate, Cr2O7 2-. All right, so in order to find the molar mass of this, we need to say, okay, well, I have 2 nitrogens, so that's 2 times the molar mass of nitrogen, which is 14.01, plus 2 times 8, we have 8 hydrogens, so that's 1.008, and we have 2 chromiums, and chromium, Cr, is, oh boy, that's, there it is, 52, and 7 oxygens, and that one is 16.00. Okay, so I can calculate all this. All right, so I say 2 times 14.01, okay, plus, now I need to start putting things in parentheses, 8 times 1.008 plus 2 times 52 plus 7 times 16, close parentheses, equals. All right, so this gives me, when I punch all that in, this gives me a molar mass of 253.028. I can only have basically 4 significant figures, so this gives me a molar mass of 253.0 grams per mole. Okay. All right, so that part was 47. Okay, so let's do C now for 49. All right, 49 says that if we have 1 gram of our ammonium dichromate, how many moles is that? So number of moles in 1 gram. Okay, so I would start out by saying, okay, if I have 1 gram, my ammonium dichromate, and the next thing I'm going to use is that molar mass that I just found that links grams per mole, so that's 253.0 grams per mole. Okay, and that is all I need to do. Okay, I just want a number of moles. I can cancel out my grams. So I would say 1 divided by 253, and that gives me, I can have 3 significant figures here, so 3.95 times 10 to the -3rd moles. Okay, if you don't want that to be in scientific notation, it could be 0.00395. That's still only 3 significant figures. And again, moles. All right, so let's move on to the part for 51 for that, which asks for the amount of mass we would have in 5 moles of that. All right, so I would say, okay, so I have, okay, so here my given is 5 moles, so I would say, okay, 5 moles, like this, times, now I'm going to continue to use that conversion factor that's going to give me grams per mole. Okay, so I would say, well, in every 1 mole of ammonium dichromate that I have 253.0 grams. Okay, so if I have 5 moles, 5 times 253, I have 1,265 grams of my ammonium dichromate. Right? All right, now 53 asks me to continue to take a look at this one substance, and it says how many, what's the mass of my nitrogen in those 5 moles. Okay, so what I can do here is I can say, okay, well, I have, in 5 moles, okay, now I'm going to use a little bit more here for my labels. 5 moles of ammonium dichromate has, okay, so I say, well, in 1 mole of ammonium dichromate, there we go, I have 2 moles of nitrogen, okay, because there's 2 nitrogens, see? All right, and then I can say, all right, and in 1 mole of nitrogen, I have, oops, sorry, I don't have an eraser, I have 14.01, there we go, grams of nitrogen. Okay, so I could say, okay, well, I have 5 moles of my compound times 2 moles of nitrogen for each one, in each 1 mole of ammonium dichromate, and 14.01 grams of nitrogen in that. Okay, so this becomes, whoops, there we go, 140.1 grams of nitrogen in 5 moles of ammonium dichromate. All right, so 2 more. Now I have 55. Okay, and it asks for the number of molecules in 1 gram of my compound. Okay, so in 1 gram of my compound, okay, now what we need to do is, if we're looking at molecules, we need to be able to link molecules to grams or molecules to moles. So I would say, okay, well, I have 253.0 grams in 1 mole. Okay, so I'm getting rid of my grams. Now I get rid of my moles by saying that in every mole, see, now I have it on the top and the bottom, I have 6.022 times 10 to the 23rd. Okay, and in this case, it's actually not molecules, but formula units. That's probably what we should be saying. Okay, so we say 1 divided by 253. Okay, times 6.022 exponent 23. Okay, and this gives me 2.38 times 10 to the 21st. We'll say formula units. And we're using formula units instead of molecules because they're compounds, not molecules, ionic compounds. All right, one more piece to this. I know this is getting long. Bear with me here. So one more piece. This is 57, asks for the number of nitrogen atoms in 1 gram. Okay, so what I'm going to do here is I'm just going to say, okay, well, I had 1 gram, and I found that I had 2.38 times 10 to the 21st formula units. In every formula unit, I have 2 nitrogens, right? Right here, 2 nitrogens. So I can just multiply this 2.38 times 10 to the 21st. I can just multiply it by 2, right? Because there's 2 nitrogens in every formula unit. So I could actually finish this out by saying formula unit, okay, and 2 nitrogens per 1 formula unit. Okay, so 2.38 exponent 21 times 2 gives me 4.76 times 10 to the 21st nitrogen atoms.